Hello and welcome to another Zozin session. How about that? Bet you didn't expect that shit to happen. Okay. So let me adjust my chat, of course. Hello, good Duk, Sarimon, Kosotia, Janus. Hello, welcome. So today I decided to make a break from the text editor development and continue developing our programming language called Bang. So it's built on top of the simple compiler ecosystem that we developed to, like, I think at the beginning of the year. I'm not quite sure. But you can find the source code of this thing in the description or in the chat if you're watching it live on stream. I'm gonna put it in the description here. Source code. Hello, Tile D4. Welcome to the stream. What was the previous episode? I don't quite remember. So let me take a look at my channel where I post all of the recordings. You can find it in here. Hello, and me. I still don't know how to pronounce your nickname, but hello. Welcome. So let me see what was the previous episode on language development, because I'm not quite sure. So we were adding local variables. Okay, so I think I know what we're gonna be doing today. Previous episode on local variables. So I've been trying to implement one feature a couple of times already, but kind of failed for different various reasons. So we need to implement an ability to call functions in our language with arguments, right? So let's actually take a look at our language itself. So it's a pretty simple imperative language. It doesn't have a lot of things, and also it doesn't even have an ability to have functions with parameters. So this is something that I wanted to fix for quite some time. I was trying to fix that, but for various reasons it was kind of not easy for me to do. So maybe today I'm going to be lucky and we finally will have function parameters in our language, hopefully. So the language itself, well, it is what it is. It's also partially my fault as well, so yeah. So the language itself also looks like this. I usually use the nim highlighting for this language, and this is implementation of rule 110, which is a cellular automaton that sort of kind of demonstrates that our language is Turing complete. So, and one of the things you cannot have in this language right now, at least, is the parameters, right? So you can't have parameters right now. So that doesn't prevent the language from being Turing complete. Alright, so let me recompile the entire thing, and see if I can demonstrate. Well, I mean, I didn't have to recompile the compiler itself. Let me just demonstrate how it fails when it tries to compile function parameters. Rule 110. Well, you have to use build. Yeah. So, expected token, it cannot even parse them, apparently. I thought I actually made it parse these things, but it doesn't really parse them, which is rather interesting. Okay, so I can probably implement that. By the way, so I recently learned that there are two sort of like there's a terminology for compilers. There are two things. There are function parameters, and there are function arguments. Who knows what's the difference between these two things? So, when you define a function, this is a function parameter. When you call a function, this is a function argument. And apparently, people, me included, confuse these two things. So parameters refer to the things that you pass into function in the definition. So this is a parameter. And argument is related to function call. So this is the argument. So when I'm talking about argument, I actually mean this thing. When I'm talking about parameters, I actually mean this thing. So that's actually pretty interesting. Why do I hear disgusting human noises in the music that distract me from programming language development? meat noises. I'm sorry. Let me see. I wonder what we can implement to demonstrate that the function argument is working. Lost algorithm. So says Lost algorithm. Thank you so much for 18 months of tier 1 subscription. Thank you. And welcome to our epic programming language development club. How about that? Be proud of being part of programming language development club. Peoples. There's so many people in here that one plural is not enough. You need double plural, right? Peoples. All right. Yes, exactly. It's like when there's too many mice, you say mices, right? So, okay, so I wonder, like, why don't I have this shit parsing properly? That's kind of strange. So if I take a look at the bang proc def, all right, so I have proc definition, but I don't have, apparently, like, I remember implementing that, but I think I just straight up deleted it. Hello, Daft Kid. Welcome to the streamers. Welcome. So we do have a fun call args, as far as I know, right? So we have a fun call args, but do we have proc params? Yeah. So we need to define them yet again. Okay, let's go ahead and do that. So this one is going to be proc param, and as usual, we're going to be using linked lists for all of that, right? Because linked lists are awesome. They're also cache friendly, by the way. They make your program go brrr. Imagine saying shit like that with a straight face. So that's what I do. And go-tos make your program readable, right? So I wanted to find proc def. So what parameter consists of, by the way? So if we take a look at the... That's why you're unemployed. That's a sick burn. Holy shit. Oh, because I say shit like that on an interview all the time, right? So that's why I'm unemployed. Hey Alexei, what do you think about Rust being adopted by Linux project? I don't know what is Rust. What is Rust? If you do, then yes, yeah. I don't know what is Rust. I'm really sorry. Like I'm not really into language Linux kernel development, so I'm not familiar with things like Rust. Is that like a Linux subsystem or something? Like I don't know. I actually deal with Go2 in my current company. Are you doing like some sort of like lower level things or something related to parsing? Rust is what happens when iron gets old. Oh, you mean literally? Yeah, so yeah, it's iron oxide. Not everybody knows, but I actually have a degree in ferrometallurgy. And ferrometallurgy is essentially a study, like a branch of chemistry that studies how to convert ferrum oxide to its metal form. So yeah, so I kind of know a thing or two about that. So yeah. I don't know how I feel about Linux actually adopting this kind of stuff, so I don't know. So let me see. Oh yeah, so the parameters. The parameter actually has a name, right? The name. And the type, right? So it has the name and the type. So this is going to be string view name, and as far as I know, we don't have a specific types in there, so we'll have to have type names. And since it's a linked list, right, which is extremely cache friendly, by the way, we'd have to have something like next in here. There we go. I'm thinking, what if it's going to be doubly linked list? I don't know. To be fair, parameters and arguments are one of these things which are not usually very long. If you think about it, if you have a function like parameter, like amount of parameters of 128, it's a really huge amount of parameters. And if you want more than this, maybe you should actually refactor your code. Do languages even have limitations on the amount of parameters and arguments? So that's kind of an interesting question. Because if we limit the amount of arguments and parameters, that will make the whole job, like my job, a little bit simpler, if you know what I'm talking about. Right, so can I just generate this shit? Python have arguments and packing, not sure what is the limit. Well, in case of the Python, it's probably very slow. So I'm just a little bit curious. Maybe we can actually write a program that generates this kind of shit, if you know what I'm talking about. So let's say that I want to have n parameters, like 5 of them, and I'm gonna do printf. So, and I'm just gonna be doing it like that. So then int a 0, right, and then for I1 less than n plus I argmax on Linux. This is actually very interesting. Argmax, what is argmax? Linux maximum size of command single arguments for a new process. All right, that's actually very interesting. So printf int a d, and then I'm gonna do printf something like this, right? So let's just compile this thing, main.c, and can I run this entire thing? Come on, man! And so this is going to be something like this, and then I suppose I'm going to be just generating a function. I wonder if I can save this entire thing to a C file, right? And then simply compile this C file like this, feed it C. Alright, so if I introduce some compilation errors in this thing, it will, you know, complain about them. Yeah, so now I can quite easily just experiment with this thing. Can I compile 10 arguments? Alright, can it compile 20 arguments? What about 32 arguments? What about 64 arguments? What about 128 arguments? What about 256 arguments? 512. Okay. Okay, so I can keep multiplying. I think it's actually, yeah, so it's actually unlimited. So, and yeah, this is the function that we managed to compile. I wonder if it's just got eliminated or something, so, yeah. So yeah, that's actually pretty funny. And I don't know, like, it's kind of a useless exercise, but I just wanted to try to do that. Right, so if I... do I have like a max int? Well, I mean, max int could be actually pretty big. What about like 1 million arguments? What about 1 million arguments? Is it gonna work? Okay, so it's taken some time, but it's not giving up. Alright. And it compiled it. So, alright, so this is a 13 megabyte file with a single function with million arguments. How about that? Isn't that amazing? I think it's goddamn fucking amazing. Void actually could be a pretty good idea. Yes. So just to try to use them or whatnot. So thank you for suggesting that. So I'm gonna give it a try. So then maybe I'm gonna just put it like this. So let me now iterate through this entire thing, and in here we're going to be doing something like 1, 2, 3, 4 void a d and this kind of thing, and yeah, this is going to be just simply I print f like this. There we go. So let's set the amount of arguments to like 10, right, and see what's going to happen. So if I recompile this entire thing, so this is the function that got generated, which is kind of weird because it looks like I forgot to put a new line in here. So yes, какова freaking this. Yep. So now, so it's gonna be million. Okay, so let's wait a little bit. Okay, so 32 megabytes, right? That's a huge file. Still compiling, but it managed to compile it. So yeah, you can have a function with million arguments. Isn't that amazing? I think it's goddamn amazing. Anyways, but dude, I didn't compile it as a runnable program. I compiled it as like a translation into an object file just to see if the compiler can handle that. All right. So I can probably remove this entire thing. So maybe at some point we'll have like a linked list of like parameters or something. I think the default stack size won't handle 1 million arguments. The question was not about stack size being able to handle that. Alright, so we have parameters and bang proc param, and we're gonna have a bunch of parameters in here. So there we go. So, and let me see, no build. So I probably need to go to the parser, right? I need to go to the parser and so parse bang proc definition, right? So, and inside of the proc definition, can I just I really want to use tag, but every time I use tag, it's actually a huge pain in the ass, so I'm not sure. Oh, I mean, I can probably use it like this. Yeah, there we go. So here we're trying to parse parameters, right? We're trying to parse parameters. Let's introduce something like bang proc param parse bang proc params. Right, so we're gonna accept the arena and we're gonna accept the Alexa, and we're just gonna simply run this entire thing. Maybe I can do something like unimplemented, you know, the usual thing. So definitely gonna move it in here. Parse bang proc params. Arena and Alexa. There we go. Arena and Alexa. So, do I have... we definitely needed some sort of an example that demonstrates that, you know, we have parameters and whatnot. So it's going to be proc main, something like this. So I'm going to probably call function 69 for 20, right? And the function f is going to be I64 and bi64. To be fair, should it return anything? I didn't think so. Let's actually not make it return anything because we don't even have an ability to return anything at all. So yeah, we don't even have such ability at all. Bin bang build full bang. There we go. Okay, so this entire thing didn't properly compile because there's no previous prototype, so I'll have to go somewhere here. Here's the proc definition. There we go. Unimplemented. Don't I have unimplemented macro? I remember having it somewhere. Alright, so yeah, so I need to move it to a different place so it can be used everywhere. So it's a very useful macro. Basically, I can put it into some place, and when the execution reaches that place, it will crash the whole application, telling me what exactly happened and where it happened. So it's pretty convenient. So let's actually make it available to everyone. So we already have an error macro. Oh, here it is. That's very interesting. So I actually moved it, but I forgot to remove it from here, apparently. Okay, so that probably means I have to do something like error.h. There we go. So let's go to the compilation of our nation. Unimplemented. Let's actually include error. Okay. Missing terminated character. Ah, yeah. Sure. So unused parameter, void arena, Alexa. Okay, so as you can see, execution went to unimplemented, and now this thing is not implemented at all. Right. So how are we going to be implementing this entire thing? Well, we have several basically cases, right? So the first one is when you don't have any arguments, then you have one arguments, and then when you have several of them. Why this is several cases? Because in the first case, you don't have anything. In the second case, you don't even have any commas. And only in the third one, you have n-1 commas, where n is the amount of arguments. So you have to have like carefully handle this kind of shit. What problems do you want to solve with your new language, or is it just a pet project? I want to solve the same problems as any programming language, creating software. So I'm not sure if you know what programming languages are used for. Do you know what they're used for? They're used for creating software. All right. So yeah. When we're parsing command line arguments, right, so we are accepting open parent, right? And then we need to check what's the next token, right? So this is going to be a bank token. This is going to be something like that. And bang, Alexa, pick. We're going to pick into the next token. So bang, token, kind, and what I expect in here is if this is a close parent, right? If we picked into this entire thing, what I notice is that it's like every freaking stream there is this circus of people in the chat until we ban them all, and then it's calm for the rest of the stream. So it's kind of interesting. There's like this initial like a wave of clowns that we need to ban first. So I guess it's just like we need to get used to that. So anyways, Mork Tech, thank you so much for 4 months of tier 1 subscription. Thank you, and welcome to our epic language development club. So yeah. We're going to have something like this, right? So it's going to have bang proc for RAM. The beginning starts here, right? So this is the beginning, then we have the end. Right, and essentially if we picked into this entire thing and we found the close parent, right? So that means we have this situation. So we consumed this thing and we have this situation. So we need to basically extract this entire thing in here. It's going to be Alexa token. So I suppose it has to be token and token kind equal bang token kind close parent. There we go. So Lexer next, and then we simply return the beginning in here. There we go. So we handled this situation. Right, if it's not closed, we're trying to parse a single parameter in here. So, and bang param prop param. So we need to allocate this entire stuff. Arena alloc, and so we need to allocate size of param. Okay, so we have a parameter, and in here we need to grab the name first, because you actually have like name and the type, right? So it's gonna be I64. There we go. So we can basically expect the token, but I don't remember if bank Lexer. Yeah, we can just simply expect the token. Lexer bang token kind name. Hello major lift. Hello. And this is basically where we take the name. So param name, right? So after that, since we consumed the initial name, the next token is going to be a colon, right? So bang Lexer expect keyword. We actually expect the token, so it's going to be Lexer bang token colon token kind colon. There we go. So we extracted the colon. So now we have this kind of situation, and now we need to extract the type name. So it's going to be param type name bang Lexer expect token Lexer bang token kind name, and there we go. So we extracted name, and now we have a situation when we either have a closing parent or a comma, right? So if after this entire thing we have a closing parent, so bang Lexer pick Lexer token 0. So token kind bang token kind holy shit. Emacs company is literally unusable quite often. Okay. Bang Lexer next Lexer token. There we go. And then, well, I should not forget to actually append the param to my linked list. So let me see. So I don't remember. Did I actually extract this entire stuff to the linked list? Yeah. So we have ll append. Apparently. So it's going to be ll append. So I provide begin and end, and then the thing that I want to actually append into the linked list. There we go. Might as well actually wrap this entire thing into like its own scope, so it doesn't leak too much, right? So the scope doesn't leak. All right. So, and in here, if we have that, we just return begin right away. There we go. So essentially, we handled this situation. So we only have this kind of stuff. Right, and essentially now we can do something like while loop. Bang Lexer pick, right, Lexer token 0, and token has to be a comma, right? Bang token kind comma. There we go. So here is the comma, and then we are materializing that comma in here. Bang Lexer next Lexer token. There we go. So that means we handle this kind of situation, and now we need to repeat this entire thing yet again. So we need to allocate the parameter, then put everything in there, and so on and so forth. So it's going to be like this. All right, so we're going to continue doing this entire stuff while the first thing is a comma. And at some point, we're going to have this kind of situation, and this is precisely where we're going to be adding the closed parent in here, and we just need to return the begin. Jia, hello, welcome to the stream. How are you doing? Hello, hello, welcome, welcome, welcome. So I think I implemented parsing the proc parameters, which is nice. I think the entire example will finally compile, hopefully. All right, so I suppose if I implemented everything correctly, right? If I implemented everything correctly, it should fail at least here, right? Because you're trying to call a non-existing function with these kind of arguments, but I don't quite remember if we handle anything about that. So basically, at least now it shouldn't fail because of the parsing problems, right? So because we addressed all of the parsing problems, we already support this kind of stuff on the level of a parser. Just a second. All right, just wanted to adjust my mic. All right, so let's try to recompile this entire stuff. All right, so token has no, I think it has to be text, right? So it has to be text. There we go. And implicit declaration of ll append. So maybe I need to do. Oh, this one is interesting. Okay. Append linked list. So. Oh, that's very interesting. Okay, so maybe I did some strange refactoring here and there. So this one has to be text. This is not what I wanted actually. Okay. So okay, so everything seems to be compiling now, and bing bang foo bang, and yeah, I should have actually started building here. Yeah, so as you can see, it doesn't fail at the compilation, at the parsing phase. Right now it says that it cannot read non-existent variable. If I try to do something like this, yeah, it will perfectly compile, right? Because this function exists and you can pass arguments in there and stuff like that. So yeah, so it makes perfect sense. But it doesn't add anything to the scope, if you know what I'm talking about. It doesn't add anything to the scope. So we have a bunch of stuff that is not needed anymore. And let's create a separate branch for function parameters, right? So it's going to be bang func parameters, right? So this is bang func parameters. Add func params to the parser, right? So we added it to the parser. So I'm thinking that we need to change the way we handle this stack. We need to change the way we handle this stack. So right now we have these stack frames, and to be fair, those stack frames kind of make everything a little bit difficult. So maybe we should change it to like a top of the stack, if you know what I mean. Like a top of the stack. So where's my tablet actually? Where is my tablet? So I really need to change the way I handle the stack, because it's not particularly helpful, I think, at least. But who knows? So right now, right. So here is the 0. Here is the where the stack starts, and we have a pointer to the like end or like beginning of the frame or something like that. So initially it points into itself, right? Then we're allocating a new frame Right, and because of that it will point in here, and then we allocate all of this stuff like in here. Right, then we create a new frame and so on and so forth. And addresses of the variables are sort of computed relative to the beginning of the frame. But what if we actually ditch the whole idea of the frames, right? What if we ditch the whole idea of the frames? So you have a stack, right? And you have a single variable that points at the top of the stack, right? It just points at the top of the stack. And when you're in a particular scope, right? And all of the variable scopes, all of the addresses of the local variables in that scopes are described as offsets, essentially offsets from the top of the stack, if you know what I mean, but it's not gonna particularly work. It's not gonna particularly work as you add more things in there, right? So it's not gonna work as you add more things in there. You still need those sort of frames. I'm just thinking, can I get rid of the stack frames, because it's kind of like tedious to work with them. But maybe not. Maybe not, maybe not. So the thing I want to do, I want to make the function, when it pushes the frame, I want it to be able to know the size of the frame or something like that. So yeah, I think I need to make a small break. I need to make a cup of tea, and then we'll think how we're going to be passing the parameters to the function, and also we need to refactor this kind of stuff. So yeah, let's make a small break and all right, let's continue. So let's actually just go ahead and try to implement passing things into the functions. So I think I can implement that in the compiler. So it's going to be bang src compiler, and where are we compiling the functions? So compile proc, maybe it's actually something like fun call. So compile bang expression. So this is where we're doing all of that. And so this is the halt. Okay, that's pretty cool. So we get compiled proc by name, and then we simply call the function. Okay, so we push the frame and we call the function, and then we pop the frame. So essentially what we need to do in here now, we need to check the arity of the function call and the function call and the function parameters, right? Function definition. All right, so I don't remember the definition of compiled proc, right? Compiled proc, so yeah, oh yeah, okay, so I think I need to get rid of the bang proc definition first. Yeah, so I do quite remember this kind of thing. All right, so we don't need this stuff. Yeah, so we need to get rid of this stuff. So the first one is going to be compiled proc, and let's just go through the compilation errors. So this one is going to be no build. So that means in here we're going to have the name is Doctor. Sorry. All right. So another one is lock. Going insane. I know. Thank you very much. Have a pretty toxic job, so I think I'm allowed to go insane. Am I? I don't know. So, yeah. All right. Thank you so much. Thank you so much, everyone, for the support. So this is going to be lock. All right, seems to be fine. Get rid of proc def from compiled. Mr. Chat. Mr. Anderson. Okay. Mr. Anderson. Alright, so... It's so addictive to say like that, it's just beautiful. Alright. So we have that, and then we're gonna have the compiler. Compiled var. So this is another thing that I wanted to get rid of. Yep. All right. So this is the definition. String view name. Another one is lock. Bang lock. Is it supposed to be funny combination of words? I don't really understand it, so I'm sorry I don't speak English. Because I see from time to time people laughing at this thing and I don't really understand why. So just keep in mind that I'm foreigner, like I don't understand shit. So is it something funny? Please let me know in the comments below. Alright, so this is a lock. Same. Yeah. Maybe there's some like joke somewhere there, but I didn't intend any joke. Oh, it's a haha sex joke. Okay, I see. Very funny. It's native speakers explains. Tea leaves. It's actually not a tea leaf, it's a branch. It's like a tea stick. Right. Right. Dev branch. It's a dev branch, sure. Okay, go. Oh shit. Get rid of bang var def in compiled var. I think that's what I did. So, you know how in languages you have global vars and local vars? Since our language is Russian, we're gonna have some vars. I'm sorry. It's the dumbest shit I've ever said. So now we have that stuff. So if I go to the compilation, compiled procedure. So I think when we're compiling procedure, right, another thing we need to put in here is the parameters, right? We need to keep track of the parameters in here. So it's going to be bang proc param. So, and in here we're going to have the parameters of the procedure: name, location, parameters, and the instruction address where it is in the instruction memory it is. Imagine programming language that uses Cyrillic alphabet. Are you baiting or what? Well, doesn't really matter whether you're baiting or not. So there's such language called OneC. So yeah, it is already a thing. I wonder if there's any examples in here, but yeah, so just Google up OneC. It is already a thing. Odin S, yeah. Compile proc definition. So in here, we just do proc params, proc def params. There we go. Compilation. Compile bang expression into bosom. So let me try to find this function. It must be here somewhere. So, and this is where we're trying to compile everything. But we never actually check the arity of arguments and stuff like that. So to check the arity, we need to calculate the amount of parameters in the procedure and amount of arguments in a function call, right? So that's probably the first thing we want to do. Do we have special functions for computing the length of the linked list? I don't quite remember. So we have ll for each. Yeah, we can just use ll for each, I suppose, maybe. Yeah, we can use ll for each. So params arity is going to be something like size t, initially 0. LL for each, type bang proc param, param proc params. Right, and then we just do params arity +1. Size t args arity, LL for each, bang fun call arg, prog, fun call args, args arity. There we go. So this is where we check the arity. Check arity. Okay. If params arity not equal args arity, we're gonna issue an error. Bang diagnostic message. Right. So what we're gonna be using actually, I think we need to use the fun call location. So here's location, and we're gonna have a diagnostic error message. So what we're gonna say in here, function svfmt expects, right, expects zu out amount of arguments, but u was provided. But got this. I think, okay, so this seems to be fine. So we arg a fun call name. So then expecting amount of argument is the params arity. Did I say something very Russian? I didn't notice, I'm sorry. Okay, so oh, OneC example, okay. LL for each. So we need to include the everything related to the linked lists. And became comrades. Don't look at the code. Don't look at the code. It's like Microsoft developers are not allowed to look at the GPL code, right? If you look at OneC code, you instantly become Russian. Oh shit. All right. Bing bang. So let's take a look at the examples we have in here. So here we're expecting 2 arguments, but let's actually provide none. Right, let's actually provide none and see how the compiler will react to that. Foo bang, and there we go. So could not read non-existing. That's fine, whatever. And it compiled, and it worked. Go figure. Go figure. So what if I provide like 1, 2, 3, 4 or something? Oh, it expects the. Oh, okay. This one is interesting. So apparently I didn't assign parameters to the compiled function or something. Expect 0. Yeah, I know. It's dumb. Bebega compiler. Yeah, it feels like when we compile the procedure, the parameters are not set, right? Or maybe they are set. I think it's the parser who doesn't. Okay, I see. It's the parser who doesn't set all of that shit. So parse bang proc params, right? So yeah, we parse the parameters, but we don't assign them to. Oh my god. The fuck? Like I just parsed this thing and I threw it away. Like that. Should have actually saved it into the file. Oh my god. My god. Truly bebega. Truly bebega. No build. Are you creating programming language? Yes, I am creating a programming language. So what's the title? Well, the title doesn't say that I'm creating programming language, right? So it says that I'm developing programming language. Could there be any confusion about whether I'm creating it or not? Depends on the definition of development, I suppose. Maybe there could be some misunderstanding in here. I use streaming. I don't know. Using Yak? No! I'm using recursive descent into madness. So it's just developing a new programming language still yet to be created. Well, I mean, it's already Hello World complete, meaning that you can implement Hello World in it. And it's also Turing complete as well. So it's already working language, believe it or not. So we have a simple example that implements rule 110. This is how the language looks like right now, by the way. It's not pretty, but it's working, right? So, and if I try to run this entire thing, example rule, well, I mean, I have to do something like run, there we go. So here is the rule 110. If you don't know what is rule 110, Google it up. Well, I mean, sure, I can Google it for you. Sure. Rule 110. Rule 34. I need to implement rule 34 in language to prove that it's Turing complete. Yeah. Holy shit, it's fucking Twitter worthy. So should I put... Well, I mean, it's very subtle. The problem is that not everybody knows what is rule 1.0, so people may misunderstand the tweet, so I'm not gonna tweet that. But holy shit, that would be actually a hilarious tweet. I'm just afraid that people will misunderstand me. But I mean, if you know what is rule 110, you probably appreciate the joke. There's no explicit BNF. Yes, there is no explicit BNF, unfortunately. Or maybe fortunately, I don't know. Well, I'm pretty sure Gia knows what is BNF. Oh, you don't know? No, very well then. I also don't know what is BNF. So some sort of like a 5-head computer science concept. You need to actually have a PhD to know what is a BNF. PhD in performance terminal rendering. BNF comes after PhD, yes. Okay, so what I want you to do, I want you to test if I fix the bug, right? So if I try to build the example, right, so it's going to be foo Bang. Yeah, expect 2 arguments but got 4. Okay, so this one is going to be 69 for 20, and yeah, so now it passes the arity check. Right. The arity check. Okay, so params arity. Param, I think it has to be something in the compiler. Params arity. Yeah, okay, so we checked this entire thing. Cool. Cool. You know what? I think I want to extract this entire stuff to a separate function, right? Right, because it's not particularly convenient to do it like that. So this is a function call, and function call get compiled procedure. So void compile bang fun call into bosom. What is arity? Well, yeah, that's the biggest whoosh I've ever seen in my entire life. Like, oh my god. So Mars Raptor obviously put this emote to like sort of hint you to a particular joke. I mean, JavaScript like doesn't give a shit about arity, and that's whoosh, whoosh. Alright, bosom. It was too loud? Was it too loud? I'm really sorry if it was too loud. Didn't mean to. Okay. So here's the function call. And I want to move this entire stuff somewhere there. Classic. Yes, it is in fact very much classic. Especially if you don't give it enough arguments, they're just going to be set to undefined. Do whatever you want with that. So it is what it is, and it isn't what it isn't. Is it not? I think it is. So this is going to be that. So bang, bosom. And what's going to be expression? Actually, it has to be bang fun call, right? So bang fun call, right? Fun call. So I have to put it like this. Fun call. There we go. Okay, no previous prototypes, so let's actually put this entire thing in here. Compile bang expression into bosom. Yep. So, and let's recompile everything. So everything seems to be all right. So I might as well even run bang. Run examples. Rule 110 bang. There we go. Cool. So this is the arity check. So I would expect to actually pass the arguments via the stack frame, right? So we want to push them into the stack frame. But how are we gonna? We need to first evaluate each individual argument, function all argument, inside of the current stack frame, right? So the idea is going to be evaluating these function call arguments into the operand stack, right? We're going to be evaluating them into the operand stack, and then we'll have to move them all into the frame once they're done evaluating or something. Yeah. So we have a bunch of arguments, right? So this is going to be argument 1, argument, maybe we're going to actually start them with 0, right? So argument 0, then argument 1, argument 2, and let's, you know, have 3 of them. So first thing we think we're going to do, we're going to just basically go through all of them and evaluate them into the stack. So it's going to be A0, A1, A2, right? So we're evaluated them. Then, so, and this is the operand stack, right? So this one is an operand stack, operand stack. So something like this. So this is the operand stack. And then we need to, that's really, then we need to pop them out and save them into the memory, right? We need to pop them out and save them into the memory, into the frame. And the question is, how are we going to be doing that in the frame? So, well, it should be relatively straightforward. So as they are in the stack, right, then we push the frame, right, and then we are sort of allocating those variables on the in the frame, so that should be fine. All right, let's give it a try. So here we check the arity, it should be fine. Compile, fun call args, so that's essentially what we're doing in here. Bank proc param, so we have a bank proc param. So this is the current param, proc params, bank fun call arg, and this one is going to be arg, and this one is going to be args. Right, so we're going to be basically iterating parameters and arguments in parallel. While we have parameters and the arguments, we're going to be compiling them and pushing them onto the stack. Though, I think we only need to iterate arguments. Yeah. So since we're evaluating only the arguments, yeah, we don't need any of this shit. And since we're just iterating through them, I can just do LL for each. Right, it's going to be bang fun call arg, arg fun call args. There we go. So that's what we have in here. So the question is, how can we evaluate the arg? That's a good question. Oh shit, after we evaluated the, like basically compiled expression, we need to check its type. We need to check its type, so that means we still need to, you know, iterate arguments and parameters in parallel. I'm sorry, so I just didn't realize that. I mean, it's totally fine. It's in the middle of development process, right? So you don't develop things like 100% correct right away. You experiment with things. That's basically the software development, right? Is it not? I think it is. Don't be afraid to experiment, right? So, yeah. All right. So arg equal to arg next, right? So this is going to be this one, and this is going to be the next one. All right. So how do I compile the expression? Compile bang. Bang expr into bosom. So we need this function, right? So I'm gonna just put it in there. We provide bang, we provide bosom, and we provide expression. As far as I know, it's inside of the arg. I think it's some sort of value, right? And here we have a compiled expression. So inside of the compiled expression, if I understand correctly, right? So compiled expr, right? We have the AST of this expression for some reason, and bank type, right? So we need to check that the compiled expression has a particular type, right? So type Oh yeah, type check, there we go, I found it. Right, so this is the function that we need in here. We can provide the expression, and expected type is the type of the parameter. So it's going to be parameter type, right, something like this. So we type check this entire thing. So we evaluated the expression, we effectively pushed it onto the stack, right, effectively pushed it onto the stack, and then type checked it. So interestingly enough, so this thing can return void, right? So it can return void, meaning that you can pass the void parameters or something. So yeah, it's kind of strange, but that's totally fine. And all right, let's try to compile this entire stuff. So this is arg, fun call args. All right. Oh yeah, so parameter doesn't have a type. Okay. Parameter doesn't have a type, which is kind of sad. But I think we can convert this thing into appropriate type. So I remember we had some function for that. Type, something type name, right? Bank type by name. So you can look up the type by name and get the actual type for this thing. All right, so, so this is going to be something like this. Param type name, bank type, right. This is going to be the type, and if this thing didn't work, we might as well exit in here. Wait, reinterpret bank expression as type. Well, it's not particularly convenient thing to have. So type argument, expression variable read. All right, so maybe it's fine. Okay, so we have that. And then we type check this entire thing. So this is the parameter type. So param type. Param type. So let's recompile this entire stuff. So the location. Do we have a location of the parameter? I don't quite remember. I guess, yeah, I guess we need to have a location of the parameter. I think I didn't provide location then. Yeah, location is not available. Yeah, or of our nation, of course. So bang proc param. So here's a bang proc param, and yeah, we definitely need the location. So bang loc. And when we parse in the parameters, parse bang proc params, right? Bang proc params. Every time we create a new parameter, we need to assign a location there, right? So the location is going to be in here, I suppose. So I might as well actually put the token like this. So, and then this is the token param loc token location. There we go. And we need to repeat this entire thing in here as well. So yeah, there's like a little bit of a copy paste, but that's fine for now at least. Okay, so so this is the name. And we're converting essentially param type name. Right. So that's what we're converting in here. All right. Seems to be compiled. Nice. So yeah, all of that could be simplified, of course. So then we type check everything. Oh yeah, so now it should be actually pretty straightforward. So if I try to compile, full bang, right. I64 is not a valid type. Cool. Forgot to negate this thing. And there we go. So what if I have a different type in here? For instance, U8, right? So something like this. Expected type U8, but got I64. Okay, so that's actually pretty cool, right? So you see, I'll have to cast this entire thing to U8 to actually pass. Okay, that makes perfect sense. Right, if I do something like this, yeah, it definitely works and perfect. Okay, cool. So we compiled all of the arguments, right? We compiled the function called arguments, and after that, they're all on the operand stack, right? But they are in a reversed order, right? So first comes the last argument, and then first one, and then the, 2, 1, 0, like reversed order. That's what I wanted to say. I don't know why it's difficult for me to speak right now, probably because the music is very loud in my ears. Now we're pushing a new frame, right? We're pushing a new frame and we're performing the call. But what's interesting is that on the call, when you call the function, the function doesn't expect the arguments to be in that specific order. Or maybe it does. Okay, that's actually quite cool. So essentially, we pushed everything into the operand stack, we prepared the new frame, and then we called the function. So on the function side, we have all of the operands in the operand stack, and we have a prepared stack frame in the local variable stack. So I suppose the next thing inside of the function that you need to do, you need to iterate through all of the arguments in the operand stack and copy them into the memory so they can use them as local variables. That actually makes sense. All right, so let's see how the operand stack is going to look like. So we have A0, A1, A2. We evaluated all of them, so we have A0, A1, A2. But after that, we also performed the call. And the call pushes the return address on top of the operand stack. So you have to be super careful. So on the function side, to prepare the frame, we'll have to swap these two arguments, then we'll have to save it into the memory, then swap this thing again, save it into the memory, then swap it again and save it into the memory, and then proceed as usual. So that's going to be basically the protocol between calling the function, right, sending the arguments and receiving arguments on the function side. So yeah, to call a function, essentially you need to put all of the arguments in the operand stack and prepare the frame stack. I think that's basically what we need to do here. So I guess that makes sense. So is everything compiled? So now we need to change how we compile procedures, right? We need to change how we compile procedures. No build. Bang compile proc, maybe compile bang proc. Where is the compile proc definition? Excuse me. Compile proc, yeah, compile proc definition. Okay, so the naming is a little bit inconsistent, so sometimes I don't understand what to do. Okay, so we get the compiled procedure. Everything is nice. We check if it already exists. If it already exists, we're not trying to do anything here. And then we're compiling the block. Okay, makes sense. Makes sense to me. So after that, I suppose we need to receive all of the arguments from the function, right? So we just need to receive all of the arguments from the function. So in the compile block, we're not doing anything except just pushing the new scope and so on and so forth. This one is rather interesting. This one is rather interesting because, yeah, now we need to inject new variables into the scope. Yeah, we need to inject all of the parameter variables into the scope. So that means we need to take the scope handling, like push a new scope and pop in the new scope from the compile block and put it outside of this entire function. So that's something that we'll need to do, but that will require a special refactoring. So before we're gonna go ahead and do this kind of refactoring, I think I need to do a committee and then maybe even push. So what we did in here is yeah, essentially we implemented compile bang fun call into bosom. So yeah, that's basically the implementation. All right, so compile, implement compile bang fun call into bosom, right? And I'm gonna push that right into the repo. Push, and even a committee. So yeah, essentially I need to just go ahead and get rid of this entire thing and go through each individual function call of this thing and wrap it with a new scope, like so. This one is rather interesting. So bang, push, new scope, bang, and then effectively pop scope, right? Bang, push, new scope, bang, pop scope. All right, so where is another function? Push new scope, bang, pop scope. I think that's it pretty much, except this one. Okay, so bang, push new scope, bang, and then you pop this scope from here, pop scope. So, and this is where we're gonna start injecting the new parameters, right? We're gonna start injecting the new parameters. But the problem is that the functions in the argument stack, they're passed in a reversed order. So and the parameters are in a completely different order. So we need to reverse a linked list. Kind of. Yes, that's what we need to do. We need to reverse a linked list now. Next thing you'll be inverting binary tree, yeah. So that's why I didn't want to use linked list for parameters and function call arguments, because I end up reversing this entire thing when I should not do that. Like, there's no point in doing that unless I actually make it sort of like a doubly linked list, so I can iterate it from like back and forth or something. Shouldn't be that difficult, but I mean, this is something that you just need to do. Or maybe just use arrays. But again, if you're gonna use arrays, like, how do you make an infinite amount of arguments? But do you really need an infinite amount of arguments? Other compilers support infinite amount of arguments, so I feel like I also need to support that. So you can support that by, you know, having arrays and constantly reallocating these arrays, but we have a special allocator. It's just like, yeah. But who uses infinite amount of arguments? So you have infinite amount of arguments in GCC, so maybe. But to be fair, really, maybe GCC just wasting their time implementing infinite amount of arguments, if you know what I'm talking about. right? Infinite amount of parameters and infinite amount of arguments, like they're just like literally wasting time, and that's why the code base is so complex in GCC. Maybe. I wonder if TCC has the limited amount of arguments. You know what I'm talking about? Because TCC is trying to be like simple, right? So maybe they do not support this kind of shit. Did I already remove my like a function generator? I should have actually tested it with different kind of arguments, different kind of compilers, right? We can try to do that. So let me see. Yeah, I already removed it. Okay, so let's quickly re-implement it, I suppose. Let's quickly re-implement it. So we're gonna have n. So printf void f int a0, right? For int 1 less than 1. All right. A, D, and this one is going to be A. Parameters in one function definition. So, guidelines. Coding guidelines. Who said this coding guidelines? Arguments in one function definitions. What is this website? Cox. Yep. Yep. It's a C standard. Oh, that's very interesting. Huh. That's very cool. So, all right. So I still want to check that just in case. I love Cox. Me too. All right. So is everything's okay? I suppose so. So this one is gonna be something like this. So compiler should support at least 127. Okay. All right. So if I have something like 5. Okay. So let's save this thing to f.c. And then, do we have TCC installed like locally, undefined? Oh, okay. Well, I mean, I can always do something like main. Right, and just, okay, so that worked. What if I have 125? Right, is it gonna be fine? Seems to be fine. 127, 256. It can support that. Okay, so all of them are supporting that. I don't know why I'm so obsessed about it. It's kind of, yeah, apparently it supports this shit. Weird. So if I want to reverse the linked list, so how would I even do that? So one of the things is that Parse, so I could make it like so, right? A single parameter is actually going to be params, right? And it's just basically going to be array names, string view for a particular capacity, right? Then type names. Right, and then next, bank from params, next. So basically you have like a list of these chunks, but is it gonna, it's not gonna help you to reverse it. So I just don't want to constantly reallocate this entire thing. If you know what I'm talking about. Though reallocation in Arena could be rather interesting. Reallocation in Arena could be rather interesting because if you allocated a chunk of a particular size and then you ask Arena to reallocate this chunk, what it may try to do, it may just try to extend the chunk instead of actually copying it or doing anything with it. So yeah, that way maybe you can reduce the loss of the memory when you're doing this kind of stuff. I think I need to think about that on a break. Let's make a small break, boys and girls. Alright, so I still cannot decide. It's hard. It's hard. So, but I can try, right? So, we can have a single parameter in here, and we could be doing reallocations and stuff. But we can also try to do something like also previous, right? So bang proc param previous, right? So we have a next. Yeah, let's actually make a doubly linked list. Can we populate the stack and reverse and make it easy to return? No. Reverse and linked list is hard. If you can do it, you get a job at Google. I don't want to work at Google, that's for sure. So here is the params. So this is only params begin. So maybe we can do something like params end, right? And you'll be able to actually iterate it backwards, right? So previous and so I need to go to this thing, right? So append linked list and double linked list. All of that is actually super inconvenient. It just like makes it more difficult to work with, right? So let's do the following thing. So the parameter is going to be a single thing, and then we're going to have a bunch of parameters in here. Bang proc params, right? We might as well actually even have params as something like this, right? So, and then we're gonna have params size. So yeah, let's actually go the reallocation path. So we'll have to go to the arena. So you can allocate stuff in the arena. And maybe you should be able to also reallocate the stuff in the arena, right? So arena, and in this particular case, I think we must provide the old size and the new size, right? Old size and the new size. So let's see how we can implement this entire thing. Arena, alloc. So essentially, since arena just like, you know, keeps allocating things and you cannot deallocate particular chunks of memory inside of the arena, reallocation essentially is going to waste memory. That's what it's going to do. It's going to just create a new chunk. And I guess that's the price we're willing to take for this entire situation. So at least for now, I suppose. To be fair, what I found while developing the compiler is that it's kind of difficult to properly manage memory in the compiler. You kind of want to just like allocate things and forget about them, right? Because a lot of things that you allocate, you will always need until the end of the compilation. Like pretty much everything you allocate is going to be used, except like chunks like this. But like you know, chasing this kind of memory is really waste of time. I don't know. So we provide the arena. We also need to provide the pointer, right? So this is going to be the pointer, and okay. All right. So we're allocating a new chunk of memory. Though, like, if you're trying to allocate smaller chunk of memory, what should we do? Okay, so if old size is less than new size, we're gonna be doing one thing. Otherwise, we're just returning the same pointer, right? So you're trying to allocate less, right? We're trying to allocate less and just like return the same pointer. But if it's a new thing, we're gonna be allocating a new chunk. All right, new PTR is gonna be arena alloc arena new size. Right, this is the new size. You will have to keep track of the old size, but we do keep track of the old size, so it's not that big of a deal. And then we copy. So this is the destination, the source is the pointer, and the amount of stuff we're copying is the, like, old size. There we go. So is this person needs to be banned? Like, I don't know. Is everything okay? Alright, so new pointer. I suppose this one is going to be something like old pointer. Right, so this is the old pointer. Arena. We don't know yet. Okay, so, well, prepare your Banheimers, I suppose. Alright, new pointer. Because recently we had a lot of weird people in this chat. So that's basically reallocation, right? So if old size is less than new size, we're allocating the new size, and we're just copying this thing and we're just returning the pointer. Okay, cool. So that should be enough. Arena.h. And when it comes to Parse, right? Maybe we should have a function that basically pushes the new parameter in there, right? Though I want to be able to actually work with different kinds of these things, right? So maybe I could create some sort of a macro. So this is obviously a dynamic array, so it's a din array push. And what it does, it accepts arena, right? Because it relocates. Maybe it could accept realloc function, right? So it accepts. Well, arena also requires the passing the parameters. So let's actually pass the arena, right? So this is the arena. We pass also the array of these things. And the size of these things, right? So this is the things that we pass in here. But most importantly, we also need to pass the type, right? Because otherwise we'll know the actual size we are reallocating. Obviously the element itself, right? So this is basically the thing that we need to push in there. And I want to make it a macro because I want to make it reusable for different kinds of dynamic arrays, if you know what I'm talking about, right? Different kinds of those things. So yeah, let's give it a try. So this is going to be 1, 2, 3, 4, do. Because I want to apply the similar thing for function calls as well. And in here, oh, you also need to keep track of the capacity. Shit. Yeah, you don't want to reallocate too much, if you know what I'm talking about. You don't want to do that. So that means you also have to have like a params capacity. Which makes it kind of eh. Alright, so that means we kind of need to move this entire thing like outside somewhere. somewhere outside. So what's the easiest way to actually work with this entire shit? Because I don't really want to pass two match arguments to this macro, right? So I can probably allocate the capacity in here, sure. But that means here I'll have to do something like this, capacity, right? So you'll have to pass so much shit in here. It's insane. There's just too much shit to pass. But maybe that's fine. Maybe that's fine. Right. So if access capacity, access size, right? So we have access size is greater or equal than capacity. We can try to extend this entire thing, right? So if access capacity equal to 0, we can say, well, it's going to be initially equal to this thing. Otherwise, we're simply going to multiply it by 2. Right. And after that, we need to reallocate the array. So access is going to be arena, realloc, arena. So this is the pointer. Old size was access capacity. Ah, shit. So yeah, you see, it's starting to have like a lot of code in here, and is it really worth it? Is it really worth it? Because otherwise... I don't know. So otherwise you would have type param and bang proc param c, which basically holds all of these items in there. Alright, so this is going to be items, this is size, and this is the capacity. Alright, so, and here you can have bang proc params, right? And to be able to work with this kind of shit, well, though now, since we have this as a structure, maybe we can actually define din array push. It will accept the arena, the access, also the type, and x. This is cool because now we're passing these three parameters via the structure. So, and then you can have a similar structure, and the only responsibility of the structure is to have these fields, right? So this is actually pretty interesting way of doing that, I think. Is it going to be din array? Maybe, yeah. So maybe proc param. Can I say something like din array of bang proc param? It's very Pascalish, I would say. If you know what I'm talking about. It's very Pascalish. So this is the item type, right? So the arena item type, din array, and item. Right. So, and so this is the parameters, din array of bang proc param. Right. So, and basically this function expects din array to be a structure that has these specific fields, and the way you use it, right? So you do din array push, you provide the arena, then you provide the params. The type that you want to provide in there is proc param, and then you can push a new param in there, and it will automatically reallocate and stuff like that, and it will automatically work with any of a structure with a similar, with similar names and stuff like that. So yeah, templates in C. We're having templates in C. That's what we're doing here. 34. So while 0, there we go. So I think it's reasonable, more or less reasonable. So then in the future we're gonna have something like din array of bang fun call args, or fun call arg, right? And I won't have to re-implement this entire macro anymore because it will automatically work. But I mean, using C macros is also a pain in the ass as well. So it is what it is, and it isn't what it isn't. Is it not? I think it is. Size. Yeah, if size is greater than this kind of shit. Transformation of our nation. Uvu nation. Okay, I'm sorry. So if size is that, I need to increase the capacity, right? So I need to increase the capacity. So if maybe I need to also create something like a new capacity, right? So this one is going to be din array capacity. If new capacity is equal to 0, right? The new capacity is going to be equal to like initial one. Right. Otherwise, we're going to simply multiply this entire thing by 2. Interestingly enough, I think it's going to be rarely reallocated. Yeah, 128 is actually a pretty good size. Especially if it's a good size and all, you know. And arena, realloc, arena. So what we are reallocating, we're essentially reallocating items. So the old size is going to be, well, yeah, capacity multiplied by size of item type, right? And the new size is basically the same thing, but the new capacity. Yes, you got it right. Did I write items? Okay. So that's what we're doing. So we're relocating this entire thing if we don't have enough space. Interestingly, if it's gonna be initially 0, I don't think it's gonna create any problems, right? So if I take a look, I don't understand the reference. It's a sorry for what reference? You just had to watch the video a little bit longer. I'm sorry. Oh shit, I'm sorry. If this thing is initially 0, right? No, Zhiga knows this meme, so yeah. We are high cultured individuals in here, alright? So we're familiar with all of the memes. Watching not that full version. So though the entire thing has a pretty, like a lot of hilarious cutscenes. You can find all of the cutscenes in the YouTube, by the way. So this is only one cutscene, which is the most famous one, but there's more actually. So yeah. Anyway. So we relocated this entire thing, and essentially I probably need to just simply, yeah, I need to reassign the capacity to, like new capacity to the capacity. There we go. So here we're just do reallocation. And after that, I can simply do din array items, din array size plus plus equal to the item. And that should be it. Pretty much. So you also have to be careful not to put any expressions in these arguments, if you know what I'm talking about, right? Because we're not wrapping anything in here with parent. Maybe we should, but that also means that if you put an expression in there, it's gonna be kind of a pain in the ass. But I don't know. So this could be. So this thing should accept a pointer. So you know what? Maybe I'm gonna pre-evaluate this entire stuff, if you know what I'm talking about. Like just basically pre-evaluate. So arena is expected. Well, if you want to pre-evaluate it, you need to know their types. Okay, so it's kind of like a waste of time then. So and in here I want to query replace the end with something like this, and it didn't work. Why didn't it work? What the fuck? Excuse me. Yeah, there we go. Now we're freaking talking. And now I can align. Boom. Can your V do that? Kick code? Alright. So maybe I can sort of like simplify this entire thing. I'm not sure. Because I kind of want to do something like this. Yeah, it's a pain in the butt. So let's actually do these things like that. New capacity, old capacity, some other shit. Yeah, okay. So here's that, and I also need to display line numbers or something like this, and let's select a line. There we go, now we're freaking talking. Cool. So more or less. I wonder if I made any mistakes in here. It should be fine. DIN array push. So maybe we also need to create like a DIN array header in here. If not defined DIN array.h. Right, so it's going to be end if. Right, and I'm going to move this entire thing in here. Right, so yeah, okay. So this is how you basically do templates in C, right? Type safe templates. Because this thing is supposed to be type safe, but at the same time you don't want to create too many like copies of functions that just push things and stuff like that. So you put it into a macro and you pass the type parameter as the parameter of the macro. So basically emulating templates but in pure C. Yeah, and it's basically like having a generic in here, right? Dynamic array of is basically the same as something like this, right? So it's just like if I need more of the different dynamic arrays, I'll have to be copy-pasting the structures, but at least I don't have to copy-paste the implementations in here, right? So that's basically what's going on in here. It's nothing new actually. It's quite common trick in pure C. All right. Super smart, you think so? Yeah, it's actually classic, I would say. So this is the old pointer, lul w, classic lul w. Okay, so dynamic array of bank param. So this entire thing was never properly defined. So let's actually put it somewhere here. So it's a type def. Lul w, no u. Okay. So this is the next. Oh shit. Why did it go in here? I think I know what the fuck is going on, mate. So I probably have to go a little bit deeper. Oh, interestingly enough. So I don't have to calculate the length of the linked list. So because arity is essentially, yeah, you do proc params and you just take the size. Okay, I should have actually done that earlier. That simplifies freaking everything. I should not be afraid to reallocate shit. All right, so yeah, I guess that makes sense. I don't know. I was too scared of reallocation. So this is the point. Is it really a pointer? So, to be fair, that's really strange. Why is it? So this is a proc, and params is not supposed to be pointer. It's actually value. What the hell are you talking about? Is a pointer? Did you mean to bank proc param? This is not right, because it is not a pointer. Am I going crazy? I feel like I'm going crazy already. Oh, yeah, I know what's going on. So this is the compiled procedure. Okay. So this is only a compiled procedure. So that means I need to go to the compiled proc. And now this is a din array of this thing, a din array of proc param. Yeah, so that now is just like this thing. Okay, so this is gonna be the compilation. Yep. So din array of bank proc param. So, and now as we iterate through these things, it's also relatively easy. Yeah, I definitely need to introduce like a din array of fun call args as well. So this is gonna be pretty juicy refactoring, not gonna lie. So let me find. So bang fun call arg. Alright, so bang fun call arg. So let's just do proc param fan call arg. There we go. So this is gonna be fan call arg. Fan call arg. So this is a single fan call arg, and let's introduce the structure of dynamic array of this shit. So we're not gonna have like any nexts or anything like that. Right, so this is gonna be, where is the fun call arg? What the fuck? Whatever. So it's gonna be size, then capacity, then bang fun call arg items. So that's how we approach that, and this one is gonna be simply din array of bang fun call arg s. I think it has to be called s, but I did already you know, name it like that. Okay, that's very interesting. Boom, and let's go to the compilation error. So identifier, I forgot the semicolon. Imagine using semicolons in 2021. Okay, so here's another thing that we're doing here. Again, yet again, you don't need that shit anymore. You can just do something like proc params fun call args size, right? So you don't have to worry about that. So and let's see. So a dynamic array proc unknown name. Did you mean unknown type dynamic array of proc? Did you mean they're literally the same? What the fuck is going on? The O capitalized. Ah, okay, so it's just Emacs being weird. Okay, thank you so much. Timeout. Don't even talk to them. Alright. So din array of, thank you so much. So this is gonna be args. So this one is essentially params. Alright. And then here what we're doing, we know that they have to be equal, right? So they have to be equal. So this is going to be something like this. Maybe we can do something like n params size 0 n plus I, and this one if it's args. All right, so args items I, right. I think we can go to the compilation error in here. I suppose we can do that. I'm not even sure if these things are needed because it's not that big of a prefix, so we can just keep it like that. Okay, fun call args items, and here it is. Fun call args items, and there we go. So, and in here is going to be proc params. It's basically params. Yeah, I think it's proc params. Items I type name, and then we extract the param name. Though it could be simplified to something like this: bang proc param, and it's going to be just basically param proc params items I. So this is the parameter, and then fun call arg, right, and this is basically fun call args items I. There we go. So parameters and arguments. This one is arg value. So then this is just a parameter type, then parameter location, type name. So yeah, this is one of the reasons why I didn't hesitated to even do this kind of stuff, because it's beneficial, but it requires a little bit of elbow grease to, you know, refactor everything. So yeah, it's one of the things, you postpone doing the right thing just because it requires a lot of refactoring, but maybe it's worth it in some particular situations, so I don't know. So we expect arity, so here everything is fine, so it means items 0, and we get the value. So yeah, that's what we need to do in here, you see. And how many places like that do we have in here, who knows? So items, though luckily the whole refactoring is rather straightforward to do. So this is just going through all of these compilation errors and just doing the thing. So what do we have in here? So right pointer. Oh yeah, and here we're sort of slowly iterating. Though, yeah, now you don't even have to do this kind of shit, to be fair. So you can just do. So this was just args, but you can do fun call args, right, items 0, and then fun call args items 1. So it's just it definitely actually became simpler. All right, man, I should have done that earlier. I didn't know why I was hesitating for so long. It's just yeah, that's the right thing to do. Okay, invalid initializer. Why is this invalid initializer? Excuse me. Incompatible types. Oh yeah, this has to be a value. There we go. Okay. It's the same pretty much shit. Alright, so this one is gonna be fun call args items 0 value. Right, something like this. The next one. Same shit. Fun call args items 0 value, but this one's gonna be 1, 2. Right. Maybe we can even give them proper names. Yeah. Call args items 0 value. Bank pop Oh, okay. So I was in the middle of a different compiler assisted refactoring session. Yeah, okay. So here we compute arity. Now you don't even have to do this kind of shit. It's just phone call args size literally. No need to even worry about that. Easy peasy lemon squeezy. 2 cars simultaneously. Yeah, that's what we're doing here. Okay, so this one has to be din array of dynamic arg. So that's essentially what we're gonna have in here, and hopefully we can do something like args and zero initialize this entire thing. Alrighty. Okay. Hopefully I'm not gonna do like significant fucky wacky and incredible oopsie doopsie. Parse bang fun call args. So this one has to be something like this. Okay, I feel like I'm on the roll. That's good. Unknown type. Oh shit. I see. I should have not renamed this thing like that. So it has to be, yeah. That explained it, because dynamic array of this thing. That explained it. Okay, so now we have to use din array push thingy. Right, do I have a din array thingy? Yeah, there we go. Let's put it in here. So, and I'm using the arena and dynamic array in this particular situation. Incredible oopsie doopsie long. Well, I mean, it is what it is. It's C. Okay, so do we have args? I provide the args. The type is bang fun call arg. So this is the type of the element, and the element we want to push in there is in fact the node, but I'm not quite sure why we are allocating it in there, because we can simply, yeah, we can simply do it like that. So it's gonna be, yeah, now we don't even have to worry about that. So it's just gonna be copying this shit in there. Right, so yeah, that's cool. Can I even do something like value like this and zero initialize? Yeah, there we go. That's cool. That's pretty poog, if I say so myself. Right. Okay. And all of that just to be able to, you know, traverse the parameters in any order. But I think it's worth it. I think it's worth it. So din array.h. It would be also kind of cool if din array didn't depend on the allocator, right? But it's kind of difficult to make it not depend on the allocator. I don't know. So it could be something like so maybe through like X macros or something, but yeah. I'll need to think about that. I'll definitely need to think about that in the future. So backslash and new line. Oh, okay, that makes sense. X macros. Yeah, they're pretty interesting. So, and in here we have. So this one could be actually called arg. Let's call it arg. This one is also arg. You don't have to allocate it. Value like this, right? And then that's what we're doing here. We're pushing the dynamic array thingy. There we go. All right. So, and then we just need to return the args. We don't have to return begin. So we'll have to do the same thing for parsing the procedures, right? Yeah, there we go. So we're parsing the procedure stuff, and it's literally the same shit. So, but that means we have to go in here. So parse.h din array of this entire thing, and it's not going to be a pointer. Right, and here is din array of this entire thing, and it's not going to be a pointer. And here we're going to have a bunch of parameters. It's initially zero initialized. Okay, go. So we parse everything, so we don't even have to do this stuff, because everything is already pre-allocated for us. param dot boom, and then we're pushing dynamic array. So provide the arena. Dynamic array in this case is params. The type is bang proc param, and the thing we're pushing is the single param. There we go. Cool. So here we're preparing the param, and then we're pushing it into this thing, and everything hopefully will be reallocated and stuff like that. Okay. So in here we are returning that stuff, so maybe we should actually return param. Then here we return param se, so that means here we have to do it like that. Okay, so here we have a similar situation. Let's replace this thing with that, and maybe here I'm gonna be just copy pasting. I said copy pasting this thing in here. Should be all right. So in here is gonna be params. Okay, is it gonna compile now? So show me what you got. Param. Oh, it's not. Yeah. I see. Okay. First try, Metaflipas. Yes, we refactored the parameters and function calls from linked lists to dynamic arrays. That's what we did. This is something that I postponed for quite some time, but I think it needs to be done because there's a lot of operations that we want to do on parameters and arguments that require them to be continuous sequence of elements. It is important. So yet again, it's been proven that linked lists are not fucking useful. Right. They're not even that useful for continuous parsing, right? It's just like, yeah, just reallocate. Okay, so the only reason why I wanted to use linked list is because like I didn't want to do a reallocation because it's arena and this is a waste memory. But interestingly enough, if we're pre-allocating always 128 elements, it's going to be super rare when we're going to be reallocating this entire thing. It's like a special, very, very special case. So we're not wasting too much memory on average anyway. If you think about that, right? Unless some sociopath will write a code generator that generates a function with million arguments. Maybe in that case, you're gonna have a lot of reallocations. Yeah, I just called myself sociopath. Anyway, so let me see. Is there anything that like, is it still working? I wonder if I completely broke this entire shit. That's a very interesting question, eh? It's gonna be example, and let's just try to run rule 110. Should have actually did run. Yo, got cooler. I actually did a pretty major refactoring, and I didn't break anything, so that's cool. Oh shit. Hello, MXQ. First try. Yeah. And do we even need linked list shit now? Do we even need that? Because maybe I can just have dynamic arrays. So yeah. So it's literally like emulating templates, right? So I'm just emulating templates. There are standardized fields for dynamic array, and you have a special macro that just assumes these fields and just can use it. And it's type safe, by the way. It is type safe because like it depends on a specific type of the element, and you won't be able to put the element of a different type in there. So, though the compilation errors might be a little bit fucky-wacky, but apart from that, it's pretty type safe, right? So, we do what we can with what we have. Can we just remove this entire linked list? I don't think we use linked list anymore, like anywhere. So, static search for types. Well, it's called type checking, isn't it? Okay, so we have that. Static assert, true. Yeah, so we don't need linked list stuff anymore. Which is kind of cool. So there's a lot of like smashed things together, so I want to kind of separate stuff related to dynamic arrays from everything else I've done so far. So this is one thing in here. So here we have dynamic arrays. So I'm gonna stash that, stash that, stash that, and stash that. Okay, so there's also arena, and we also removed the linked list. All right, so this honk is gonna be stashed. The honk needs to be stashed. Here's another honk to stash. Parse prog shite. Okay, so this one also got refactored. And here we're checking arity. Pretty much everything we've done so far, I think, related to this kind of thing, but I'm not 100% sure. So this is the arity shit. So this is another thing. Okay, and here we have like a different different car already. Yeah, so this is a completely different car, except this one, yeah. And the compiler probably became faster, by the way. Speaking of, it probably became faster, right? We have a raid from Mr. Halsey. Thank you so much for the raid with 35 opened browser tabs. I really appreciate it. So we're programming in pure C. We're developing our own programming language. So hello, hello. We just refactored our code from using linked lists to dynamic arrays. And that was pretty cool, not gonna lie. Okay, so replace linked lists with dynamic arrays, right? Or they're also known like stretchy buffers, or you know, in the C++ world they're also known as vectors for whatever freaking reason. So I suppose in C++ they're known as vectors just to annoy people. Ganoim Banana, thank you so much for 12 months for a year of tier 1 subscription. Thank you, thank you, thank you. He's creating an IDE, not just an editor. So, thank you so much for your support. Let me see. Compile block into bosom. Okay, so here's another call, here's another one. It's wrapped with scopes. And all of the calls to compile block into bosom are wrapped into a new scope. Yes, programming language. I think they didn't notice. Anyway, thank you so much for the subscription. We're developing the text editor today. Can I just put like a text editor into the title and nobody will, you know, notice that I'm not developing that? All right. Okay. Move scope managing outside of compile block into bosom. Right, so we're gonna push that right into the repo mate. Right into the repo mate. Okay, good. So, and what was the reason why we did all this shit? It's because as we... Yeah, so I went on such a huge tangent that I forgot what I was doing. So when we pass in the arguments to the function, right, so we're pushing them into the operand stack, and then we perform the call. Right, so the next thing we need to do, we need to pull them off of the operand stack. Right, we need to pull them off of the operand stack and put them into the frame. Right, that's what we need to do. We need to put them into the frame. Interestingly enough, so where is the compile? Yeah, so here it is. So we push the bang. And I suppose what I need to do, I just need to start iterating the parameters, right? So size t, but I need to iterate them from the end, right? I need to iterate them from the end. So how are we going to be doing all of that? We're going to be doing all of that by doing bang. where's the parameter? Okay, so here are the parameters. So it's going to be something like proc params size I greater than 0 minus I. There we go. So, and the current parameter, so it's going to be bang proc param is going to be proc params items I minus 1. There we go. So, and here we have the parameter. Next thing I want to do, I want to compile this parameter as a local variable. That's what I want to do. So I need to compile it as a local variable. Compile local, maybe something like stack var. Compile variable definition into bosom, right? So, and how do you do that? Compile variable definition. So I'm going to go into the compile, and in here, so we have a type. Oh yeah. Okay. So this one may require another kind of refactoring. Yeah. This one may require another kind of refactoring that I probably want to do after a small break. Yeah. Because here's the problem. So we can only introduce variables from a variable definition. But since we're introducing procedure arguments, we are going to have variables that are introduced by precision arguments, but not variable definitions. So that means we need to be able to compile variables regardless of their definition, essentially, right? So it's not going to be about the definition. It's more about, yeah, so maybe we can just accept. So what do we use var def for? What do we use var def for? I think we use it for location and some other stuff or some other shit. So new variable, so it does have location. It also has initialization and whatnot. So, well, initialization is essentially, yeah, it's only applicable to, yeah, we need to actually pull this function apart into smaller pieces that could be reusable for the procedure parameters. That's what we need to do, but we're gonna do that after a small break because I want to make a cup of tea. That's what I want to do. So let's make a small break. All right, so let's try to understand how to tear apart this specific function. We can call it something like compile var into bosom, right? So it's going to be void compile var into bosom, and in here we're obviously going to be accepting the context, right? But instead of the variable definition, we're going to be accepting things like the name of the variable, right? So this is going to be the name, and also the type of the variable, and the storage, right? So where precisely this entire thing is going to be located. On top of that, we probably also need the location, right? So it's going to be bang loc, like where it is defined initially. So yeah, I suppose because compiled variable, right? Compiled variable does store its location. So here it is, name, location, type, and storage. And once everything is done, we also put the address in there. So that's the function we want to have. It's not a function we deserve per se, but that's the function we need. That's for sure. Okay, so I'm gonna go here. Compile var definition, I'm gonna put it there, and I'm gonna simply just put it in here and go through the compilation errors and maybe go through the entire function. Right, so we already have the type, we don't need that shit anymore, and maybe we need to check the type. Yeah, so defining variables is not allowed, so this one is just the definition. So checking for existing variable, right? So we're just checking for existing variable. Alright, so we check in the scope. We don't need to have a variable definition in here. If it already exists, we use the location that is provided in here, and we use the name that is provided in here. So here's the name, blah blah blah. Does not warn about unused variables, so we also check for the shadowing of the variable. The shadowing of the variable. So if warnings as errors, we're gonna be reporting it like that. So we already even have like a warning system, right? And that's a pretty self-explanatory code. Like quite rarely you encounter such a self-explanatory code. Errors, warnings as errors, if it's true, just fucking exit in this particular case, right? So yeah. Like, I like simple imperative programs. I don't know why people are so scared of imperative programming in 2021. Because a straightforward imperative programming could be so much freaking readable than any freaking FP or OOP. Do you try to allocating on the heap? From time to time, in the privacy of my bedroom, I do try allocating on the heap. Avoiding. I didn't really avoid allocating on the heap. I think like it's pretty natural for people to allocate on the heap, so I don't try to avoid it. So if you're interested in how I'm managing the memory, I have an arena allocator. So let me find it. All right. And essentially, every time you ask Arena to allocate a memory, it grabs the memory from already pre-allocated chunk, right? So, and if it runs out of memory in that particular chunk, it calls malloc again, right? And the cool thing about this arena is that once you've done, you can deallocate the entire memory at once. Right, you just deallocated the entire memory at once, and you don't have to keep track of what was allocated where. Like, no. You're done with the compilation. You just deallocate all of the buffers at once, and that's pretty cool. So that's how I do that. So I don't really avoid, right? It's just like I build a system in front of malloc that tries to call malloc as few times as possible, if you know what I mean. So. Also, using malloc is quite slow because malloc tries to be as generic as possible, and because of that it uses some fancy data structures to keep track of the state of the heap, right? And if you have a fragmented heap, it's just like, you know, needs to look up shit, and it's just like, bruh, come on, just give me some memory, right? So, yeah. There was some... Oh, I know what you're talking about. It's the continuation of Casey Adventures, right? Wait a second. Twitter is going to see Muratori. Oh. Where is that link? Yeah, this one. I know precisely what you're talking about. So somebody wrote a criticism of ref term. So it's actually quite fucking amazing. So I'm gonna put it in the chat, and also I'm gonna put it in the description for anyone who's interested. Right, so looking at the performance of ref term, so it's gonna be somewhere here. Right. So something about bat. Yeah. So here's the criticism. The code is arranged in a very non-standard way. There are two main source files, OneC and OneC++, that are built with a bat file. Those files first define a bunch of stuff and then include all other stuff directly. This is a very old school and against pretty much any recommended best practices in C. This works well for a single person project, but big hurdle for new contributors. Focus on that. A big hurdle for new contributors. A big hurdle for new contributors. Resource consumption was measured by checking out the code, building it with a bat as instructed by upstream. Imagine freaking project that is as easy to build as just calling a bat. Big hurdle for new contributors, built with a single call to bat file. How dense can you be? I don't even know how to explain. Holy shit. I just... and the entire article is like that. Oh my god. It's just like, it's really painful to read. I don't understand people, seriously. Terminal emulated in the electron. Yes. Okay, so let's continue. And used param something. Oh yeah. So I was actually working on something. Yeah, compile var into bottom. Var into bosom. Then we're doing that. So yeah. New variable, we assign the name, the location, the type, and the storage. Right. So the type and the storage, and here is the address. All right. So global variables cannot be initialized right now. So do I want to keep it in here, to be fair? I'm not sure. To be fair, I think the initialization has to be done outside of this thing. Right, yeah, it has to be done outside of this thing. So I think everything related to the initialization should go away. Right, so this is unreachable, and then we push a new var into this entire... It's pretty good. So that's pretty much it. I understand if it was bash script on top of manual downloading 56 dependencies and building them by hands. Yeah. Alrighty, so can I now compile this entire thingy and use variable param? Yeah, so I think I'm going to just comment it out for now. But, no, it's actually fine. It's actually pretty good that it throws a warning. Compile var definition into bosom. Right, and in here, I'm going to be doing that, but we don't need to do that. We already have done that. We already have done that. And pretty much that as well. Right. So in here, I just want to call this function, but I think it also should return the compiled variable. Yeah, I think it should return the compiled var. Compiled var. New var, and here we're just like, returning the new var. Compiled var. Okay. So here's the compiled var. var. And I'm gonna be compiling this entire shit like so. Okay. So here's the bang, bosom. The location here is the variable definition location, then variable definition name, the type that we just extracted, and the storage. We already provided the storage for this entire thing. So here it is. So depending on the storage, we can call it new var, why not? Right, and if variable definition has initialization, we say that it's not possible to do this kind of shit. Right, and the variable definition has this kind of thing, so we extract this stuff, and then we do that, and that. We don't even need to push anything in here. There we go, I think. I tear the function apart, and now it can be reused for compiling the parameters as well, which is pretty fucking nice. Okay, so let's see if it compiles. Tear me apart, senpai. Sure. So here's the storage. What the hell is wrong with storage? Expected. Well, I mean, you asked for it. Okay. So where is the compile variable thingy? Turn apart, please. Oh, freaking classic. Okay. So it's going to bang, bosom. Location will come from param location, param name. The type, the type is rather interesting. So yeah, I'll have to copy paste this thing. And storage, I suppose, is going to be just bang var stack storage. We're just allocating this shite on this stack. Yeah, we need to extract the type. So compile var definition into bosom. So I need to copy this thing. It has to be copied like that. There we go. So here's the type. So instead of var definition in this case, var definition, we're gonna just have a param. Boom, 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 boom. I want you in my room. Let's spend the night together, together in my room. Okay. So I think that is it. So we push in the scope and this is not really it. I think this is not really it because now we have to, yeah. We don't really have to iterate it in this specific order. You know what I'm talking about? But it's gonna be fine. All right. Impersonation of high school career. Thank you so much. So here's the stack. You're welcome, Ralph. Right, so the first thing I want to do, essentially, I want to swap these two things, right? So to do that, I'll need to do bosom push instruction, right? So I push it into the bosom, and instruction is going to be instruction swap, and we're swapping everything from like with a 1. So it's going to be word u64 1. So that's what we did. Now I want to actually save that value to that specific variable. So I do remember that there was like a function for that, but I forgot its name. Typed write, right? So yeah, that's pretty cool. So but you need to have an address. Compile var write var assign. What was that actually? Var assign, yeah, bang var assign into bosom. So it accepts this kind of thing. So it accepts the variable address. Right, it accepts the variable address. And the value and stuff like that. Alright, so can I just do something like this, and this is going to be var, right? Compiled var, and here is the var. Okay, and what's interesting is that you have that, then you have the address of the variable here now, right? So then you compile the expression, but we already have the compiled expression, right? Here it is. So that means that we need to swap this entire shit yet again like so. Right, so let's put another swap in here. Right, so on the top we have a return, and we swap return with an argument, and we get the argument on the top. Then we put an address on the variable, and we swap it again to get everything in the right order. Right, after that we need to perform typed write. Right, we're performing typed write, and the expression, the type that we're using in here, I think the type should be available in the variable itself. And after that typed write, this thing is going to consume like everything. And basically we're going to do that n times, where n is the amount of parameters. So we're going to do that, then push the address of the variable to write, swap it again, consume it. That, address, that, consume it, and until you have a return, and all of the arguments, all the function arguments were moved to the memory. So that's basically how we prepare the local variables and stuff like that. So that's basically everything I wanted to do. And that effectively should be it if I didn't do any significant fucky-wacky and, you know, any critical oopsie-doopsie. So let's go ahead and try to compile this entire shit. Is it gonna compile? Is it gonna compile? We'll see, we'll see. It has to be a pointer. A pointer. Compiles. This entire thing seems to be compiling, but does it even work? I don't know, we're about to find out, I suppose. We're about to find out. I'm actually kind of scared to check that. So let's come up with an interesting example, I suppose. I suppose we can come up with an interesting example. So here's going to be full bang. What we're going to be passing in there? We have a new subscription from Niles Lurches. Thank you so much for tier 1 subscription, your first subscription, by the way, and welcome to our epic compiler development club. That's what we do. We develop the compiler. So let's create a function that prints a message, right? So it is going to accept the message as the pointer in here and also message size. And essentially, it is going to wrap the message into some sort of like, you know, box, right? So we're gonna put 2 lines in here, like this, and then I'm gonna do write ptr message message size, and in here we can try to generate the message somehow. So to generate the message, let's actually create a heap base. So this is a magical variable that is going to be populated with the address where it starts the heap, so we can put something in there, right? So, and we can populate the heap with, you know, English alphabet or something like that. So let's give it a try. We're gonna create like I64 is gonna be initially 0, while I is less than 26. We're gonna be doing the following thing. So we're gonna store pointer. The thing that we're storing in here is gonna be U8. The address is effectively heap base plus cast to pointer I, right? So we're just offsetting this entire thing. And in here I need to take I and add, I suppose, the ASCII code of A. So let me see. So 65, right? So, but that needs to be casted to this thing. There we go. So we store the pointer. So here we're effectively generating the English alphabet, right? And here we also should not forget to increment the I. And after that, we can try to call the message. So the message is going to be heap base, and the amount of, the size of the message is going to be 26. We can also probably assign this thing to a variable. I64 is going to be 26, and we can, you know, centralize this entire thing like so. This should compile, right? Theoretically. But in practice, who knows? Who knows? I don't know. I think I considered everything. There shouldn't be any, you know, significant oopsie-doopsie and fucky-wacky. Do you plan on adding generics to bank? Yes, of course. It depends on what you mean by generics. So I'm thinking of like being able to pass types as arguments to functions, which is effectively generics. So look, we already have a function that stores something to a pointer, and in here I actually pass type as an argument. So, but this function is hard-coded. So in the future, I actually plan to allow the user to define such functions themselves, right? We'll see how it goes. So, but already this is the type. So there's no such variable in here. You literally put the type in here. So yeah, right now you cannot define such function. It's a magical function. Compiler intrinsic. I think this is how they're called. Magical functions are called compiler intrinsic. So yes. Okay, let me see. So can I, first I want to try to run something like bing bang run examples rule 110, and it already fucking broke everything, so nice. So yeah, even passing shit around already doesn't work. So interestingly, I think rule 110 right now is kind of like broken. Yeah, this shit is not supposed. Yeah, I see. Because main is not supposed to be accepting any arguments. So I hope that's the problem in here. I really hope so. Okay, so let me try to. Oh, yeah, that was the problem. So main was accepting the arguments, and that was like the actual problem. So maybe I should, you know, look into that. Fail bank should fail compilation if main function accepts any arguments, right? So right now the compiler generates the code that tries to accept the arguments and corrupts the stack because of that. So that's basically what happens. So we don't want this kind of shit to happen. So that's pretty pow, not gonna lie. Okay. So this is gonna be no build. And then I'm gonna do bin bang run. Is it gonna be first try? Is it gonna be first try? Hell yeah, brother, K-Kona! Yeah, it worked exactly as it's supposed to actually work. Well, the only thing I technically forgot is to like put a new line in there. Right, so if I do something like this, now there we go, we have this kind of thing, but it successfully passed the arguments to this function. As you can see, it successfully passed this kind of shit, so that's pretty cool. So yeah, we generated this thing, we passed this stuff, and yeah, if I put 5 in here, yeah, it seems to be working. We can try to implement like a recursive Fibonacci or something like that, so it could be something like yeah, proc fib n I64. So how are we gonna be? Well, okay. We cannot return anything from the function yet. I wonder how we're gonna be implementing that actually. So that'll be kind of interesting, I think. That will be really, really interesting, but yeah. So we can return that via the stack as well, why not? So that's one of the things we can do. We can just return it via the stack. Okay, so yeah, so there's no really way for printing numbers right now, so yeah. Let me go ahead and just commit whatever we have. Maybe I can use this in a rule 110, if you know what I'm talking about. How can I use that in a rule 110? So we can print the current state, but we can have a function that effectively accepts print state, where this state is a pointer, so you can just basically decide which state you're using and stuff like that. That will be rather interesting. And because of that, like, you don't have to do state current or anything, right? So this is gonna be state current. So next state, yeah, that will be rather interesting. So this is going to be the state, right? And I wonder, is it gonna fail? So next state, so you have state next and state. So state state previous, right? So it's gonna be pointer, and state next, it's also gonna be a point. Well, shit, it's actually okay. That's all right. I don't know how to call them, because state next and state current are already taken. They're indices, right? So they're effectively indices. Right, and maybe because of that we have to call it an index. Right, so it's going to be an index. Though, wait a second, why state index is this shit? Excuse me. State next. It must be a local variable. Okay, so we identified another place for a local variable. Alright, so let me try to recompile this entire shit and just run the example. Example, rule 110, and let's go through this entire shit. So state. Okay, state is already a pointer. Right, so that means I can just put something like this. It's a state base rather. Okay. So if we have state base, maybe we can also accept display as a pointer here. That would be kind of cool. So we have state and display. Yeah, so print state, here is the state and here is the display. But you also need to pass the sizes and whatnot, so I'm not sure how good this entire thing it is, but we can try. So if we're going to be passing like states like that, does it make sense to... I'm actually thinking because of the parameters and function calls, we'll be able to completely get rid of the local variables, of the global variables, except heap base. Shit, that's actually cool. I think we should be able to do that. So here's the state. So display size depends, I suppose, on a state size. And the state size is essentially a 30. Okay. So here we can accept state size as I64. Right, so you have a state, state size, and display, and essentially this thing copies data from one place to another one, knowing this kind of stuff, right? And also because of that, I think I'm gonna actually move these functions down below, right? So they're not visible to anyone else. And because of that, maybe it would make sense to do all of the initialization in here, so there is no, like, you know, global variables, right? So table size is going to be this thing, so this is the pointer. Then we have table size like this. Oh shit, table must be table must be global probably, but maybe not. Maybe it's not that important. So okay, state size is going to be this kind of thing, I64. State current also I64. Right, so I64. Then state base also I64. Then we initialize everything, and here we have a display base, which is a pointer. Base here has to be a pointer as well, right? So table. Yeah, I actually want to remove all of this shit. So only heap base. Only heap base, no initialization and stuff like that. When we do the display, we use the display thingy. Okay, so let me try to recompile. Could not a non-existent. Okay, state base. So in my opinion, you just have to do state cast ptr and that's it. So this is going to be like this. So display base. Right, in this case it's just display, and this in this case it's just that. Display, state next. Yeah, I'm writing my language in C, so this is how the language looks like right now. So this is the state current. Though, yeah, I think it has to be slightly different, so we have to accept this kind of stuff. So state current is going to be just a pointer, then state next is going to be also just a pointer, and also we need state size, which is I64. Okay, and we don't even need to do any of this stuff, right? I think the code is actually shrinking. I think it's kind of shrinking, but I'm 10% sure. We'll see if it is actually shrinking. All right, so could not assign. Okay, so table index. And 64. Well, table index apparently is U8. Okay. State base state current size. So this is the current state. So this is the current state. So that means I can just take this entire thing and add it to here. So this is the cell pointer. So is cell pointer even used anywhere outside of these things? I don't think it is used anywhere outside. I might as well just put this entire thing here. All right. Okay. I wonder if I completely broke this thing. So. All right. State current, so that means it has to be, yeah, the state current. Do we even need to have, yeah, we need state size. Oh shit. State current, and this one is just, okay. State current. I'm a little bit afraid that I'm gonna actually break everything. Just a little bit. But not too much. Okay, so this is the state current. State single one. Table base. Alright, so this one is interesting. So I think we need to also pass the table. So table. So it's called table base, but I think it's going to be just this. And then table size. Do we even use table size anywhere? I don't think so. So yeah. So we're going to be just only passing the table in here. Alright, so this is the table index. State next. This one is interesting. State next. This one is just one. Unknown print. Okay, this is actually pretty pogue. So we only have two functions. The first one prints the state. Right, so it uses the display and the state size, and another one computes the next state. Right, it accepts the current state, the next state, the size, and the table for replacement and stuff like that. All of that is initialized in here. Alright, so this is the current. So what I'm essentially doing, so I'm printing the entire thing. Alright, so this is the print state. So the state in this particular case is going to be state current. So that means it's a state base plus state size multiplied by state current. Right, so this is the current state. We need to cast this entire thing to I6 to the pointer, right? Otherwise it's not going to work properly. Right, and then we pass the pointer, and then we also need to pass the display. This is just the display base. There we go. So we printed the state like this. Right, so this is the current state. Cool. So now we need to calculate the next state. The next state. There we go. So it's going to be something like this. The current state is something like that. Right. The next state is actually... yeah, we actually have to compute it like this. So state next is going to be equal to 1 minus state current, right, like this. Then this one is a state next. The state size is passed like this, and then also we pass the base table. So that's pretty much it. the fuck is going on? Okay. So, and then I reassign state current to state next. All right, so yeah. So this is basically the refactoring that we've done so far. I'm not sure if it became simpler, but at least we don't have any global variables except this heap base, and that's what I wanted to achieve. I wonder if this entire shit compiles. So we're about to find out. Could not read non-existent. Okay, so this is a state base. Why don't you have a state? Oh, it's a states base. All right. States. Okay, code. And this is the states. Work first try. So, and what kind of refactoring did we do? So that's basically the refactoring. So we got rid of the global variables because we implemented the parameters, right? So now we pass different regions of memory as the parameters for the functions for rule 110, and rule 110 became a little bit more compressed, right? So just, yes, that's pretty cool. Pretty much first try this entire thing. That's cool. I don't know. I think if I fuck up anything in here, right? So I don't know. Instead of like pointer, I will put an integer in here. It will even tell me that I'm using like, yeah, expected pointer, but got i64, as you can see. So it's statically typed. It checks all of the types and stuff like that, so it won't allow you to do stupid things. Yeah, that's pretty cool. That is in fact pretty cool. So the only thing we're missing is that being able to return arguments from the function. It's not like we need it in here, but it would be nice to have. Right, so maybe I'm gonna put some to do in here. So bank does not support procedures that return, you know, results, some sort of results. So this is going to be another to do. All right, so let's do a committee. So what did I do in here? I think how to explain what I did. So we essentially made procedures accept the arguments, right? But we did that for the compile proc definition into boson. Okay, make this thing accept args params properly. Okay, so and let's push that right into the repo. So my idea is that as we add more and more features, the rule 110 implementation should become more and more compressed, if you know what I mean, and more type safe and so on and so forth. So over time, this sort of like example that demonstrates that the language is string complete should become better and better and more readable and more maintainable, whatever that's supposed to mean, if you know what I'm talking about, because the words readability and maintainability are so overused in 2021, they don't mean anything at all. So it's like every time like I have to say readability or maintainability, I have to cringe, because people say this kind of shit in all sorts of context, meaning all sorts of shit that it just lost meaning. So it's better not to say things like that. But anyway, so I guess that's it for the day. Today was a pretty productive stream, not gonna lie, I really enjoyed it. Thanks everyone who's watching right now, I really appreciate it. Have a good one, and I see you all next time. I don't know when, I don't know where, but we'll see. The winner gets tea, that's for sure. Check out, you know, the project, check out links in description if you're watching this on YouTube. And I gotta go. Thanks everyone for watching. Love you.